Randomization is also a very powerful technique, and I've done a few efficient randomized algorithms, random sampling. The most interesting example is the randomized algorithm I developed with David Karger and Klein to find minimum spanning tree in linear time. It uses random sampling, and it uses recursion, and interestingly, it's got the same property as the median finding algorithm that I did back in Stanford. It uses recursion in two places in fundamentally different ways, and you put the thing together in the right way, you get a linear time algorithm. But randomization is critical in security, crypto, and so on, and it helps in a lot of algorithmic situations. It's still open whether this problem can be solved deterministically in linear time. It's a very peculiar situation, and again, inverse Ackermann function comes in here. So Bernard Chazelle developed a deterministic algorithm that runs in linear times inverse Ackermann function time. That algorithm was modified by Petty and Ramachandran to produce an algorithm that runs in optimum time to within a constant factor. But they don't know what the bound is. So there is an optimum deterministic algorithm, but what its running time is, nobody knows. How can this be, you ask? The answer is another general technique. These minimum spanning tree algorithms use essentially parallelism in a very heavy way. They do a recursion that very rapidly reduces the problem to tiny little subproblems. And if the subproblems are small enough, you can enumerate all possible algorithms, decide the best one, and apply it. The number of possible algorithms to solve the tiny subproblems, even though it's super exponential in the problem size, it can be arbitrarily sublinear in the size of the big problems. So you can get the optimum algorithm for all little subproblems and just do a table lookup. So you run this thing, and the recursion turns out to be only constant depth, and then you get an algorithm, but you don't know the bound for these optimum tiny algorithms that you computed by brute force. So a very strange situation.